Okay, so subdivisions in runtime memory. It has target code, statistic data objects, and dynamic data objects, as well as autonomic data objects. In target code, the program code is static as its size can be determined at the compile time. So basically जो प्रोग्राम कोड होता है वो स्टैटिक में होता है, यानी सिंपल लैंग्वेजेस में. दैट इज़ बिकॉज क्योंकि उसकी जो साइज़ होती है वो हम डिटरमाइन कर सकते हैं एट द टाइम ऑफ कंपाइलेशन. आफ्टर दैट इसका मेन स्ट्रक्चर कुछ ऐसा है: द कोड एरिया, द ग्लोबल स्टैटिक एरिया, स्टैक एंड हिप. And the main thing is stack grows towards higher memory, heap goes towards lower memory, stack grows towards higher memory. तो ऐसा क्यों होता है? The basic thing is static storage allocation. Static storage जो allocate करते हैं हम, उसके अंदर names and memories are decided by compiler. So names and memories are decided by compiler, and values are stick around between the functional call. Function call has values which are stick between. Values can stick around between function call. Memory is set during compile time, not flexible. The memory is set during the compile time, जो कि ये जो टारगेट कोड है उसके अंदर हमने प्रोग्राम कोड डिफाइन किया था, उसकी साइज़ ऑलरेडी यहाँ पे डिफाइन कर चुके हैं. दैट्स वाई इन स्टैटिक स्टोरेज द मेमोरी इज सेट ड्यूरिंग द कंपाइल टाइम, which is not flexible because we might need it more. Not supports for dynamic structure or recursion. As this is a static storage allocation, no dynamic structures or recursion is done, because recursion comes under dynamic, and dynamic structures that are like stack and LIFO, that is not considered in static storage allocation. That's why no support for dynamic storage for recursion. Coming to stack storage allocation, memory organized like a stack LIFO. Now stack is what? Stack is 1 second data and then third data, like this, like a stack from top to bottom, bottom to up, which is last in, first out. That is because a stack can contain data, and the data on the up, the topmost end, that is last data, that can be used directly. That's why stack storage allocation has a memory organized just like a stack, which is in LIFO. You can take out only this, you cannot take this element. Each function gets fresh storage for its variable. Now each function gets a fresh storage for its variable, whereas in this the memory is limited, it's not flexible. That's why you cannot give a fresh function every time storage, because storage can be increased according to whatever we need. Only the thing is, the functions which are in the last bottom of the stack, you will remove it only after removing all these elements. So each function gets fresh storage for its variable, like x, y, z, like this. Now supports recursion. Now just because recursion is a data structure topic, it is comes under the stack storage. We can support recursion in stack storage allocation. Heap storage allocation. Memory can be allocated and freed anytime. Now this was in stack storage allocation, the problem was memory was in stack. That's why you can only take this element and then remove it again, whereas in this the memory was in fixed size. That's why you cannot like assign data directly or remove it, whereas in heap storage allocation, memory can be allocated and freed anytime. Use of dynamic memory needs. Now, as we are using dynamic memory, the data structures can be stored. Anything, recursion, heap, stack, everything can be stored in heap storage allocation. It supports recursion. It supports recursion just like stack, but in static storage allocation, only recursion is not supported. That's the only difference in it. So let's give a recap of what we studied today. Subdivisions of runtime memory: target code, static data objects, dynamic data objects, and autonomic data objects. So in all four of this, target code basically has a program code which is written in statically, means line by line, and its size is determined at the time of compile time. So target code has a program which is static, its size is determined at the compile time. Now in static data object, it has the basic object, it does not has recursion or heap. But in dynamic data object, heap can be stored. Automatic data objects, stack can be stored. Now the diagram of subdivision of runtime memory is just like this: code area, global static area, stack, and heap. And there is arrow because this is going from lower to higher, and it is going from higher memory to lower. So the stack grows towards higher memory, heap grows towards lower memory, like I told here. Now let's go to static storage allocation. Names and memory are determined by compiler. Values are sticked around between function calls. Values are sticked around or between function call. Memory is set during compile time, not flexible like the program code, where the determined of compile time is given at the size of the target code. Just like that, in static storage allocation, no support for dynamic structures for recursion because we have allocated memory which sets at the time of compile time, and it's not flexible for further information gathering. Now let's go to stack storage allocation. Memory organized like a stack, that is in LIFO, last in first out. So if your elements are like this, Z will come out first, and then Y, and then X. Now each function gets fresh storage for its variable. Like I said, X, Y, Z supports recursion. Coming back to heap storage allocation. Now heap storage allocation has a memory which can be allocated anywhere, and it can be freed at any time, and it also uses dynamic memory. That's why we can support recursion just like we can do it in stack storage flow. That's all for this video. Okay, bye.